So, we got a lot to do. I know you're all excited about your impending trip, but let's try to stay focused. Ready? Practice test. We are on problem number 11 on practice test 2. This is where we left off yesterday. So our goal is to finish this one and practice test 3 today. And then tomorrow, I've got some additional review. I'll get you to the board and stuff like that. So here we go, number 11. Which are polynomials? Don't get careless. Remember, these are yes and no questions, but if there's a no, you have to explain why. So let's look at A, 11A.
Yes. Or no.
11A is a no. I'm on practice test 2. Make sure you're on practice test 2. 11A is a no because variable in the denominator. Good. How about B?
Yes.
B is a yes. Nothing wrong with B. Everybody in agreement? All right. What about C?
Yes.
That's a yes. Now that's my trick question because I stuck a radical in there, right? But the radical doesn't have anything to do with the variable, so we're all good. C is a yes. What about D? That's a no because there's a radical over, the variable's under the radical, right? And what about E?
Yes.
That's another yes. Lots of yeses. Let's review those rules real quick. We know we can't have a variable in the denominator and we can't have a variable under the radical. What are the other 2 rules?
Negative exponent.
No negative exponents, no fractional exponents. Right, we got that. Did you put it back there, Adam?
Yes.
Okay. All right, number 12. Write the equation of the linear function where f of 1 is 4 and f of 3 is 8. All right, so the very first thing, hopefully, you think when you look at this problem is, Ava, this is a point, right? This is the point, what point, Ava? 1, 4, very good. And this is the point 3, 8, perfect. So when we're writing the equation of the linear function, that means we are thinking about y equals mx plus b, a line, and we need to find m. So 8 minus 4, y minus y over 3 minus 1, 4 over 2. I heard somebody say 2. I think you were right. Okay, then what?
Plug it in.
Pick a point. I'll just pick that one and I'll plug it into here. So 4 equals 2 times 1 plus b. That's y equals mx plus b. So, oh gosh, b is also 2. So what do I write in the answer blank? Y equals? 2x plus 2. Very good. Now the next one says we want a quadratic function. Gang, quadratic function is just a fancy way of saying parabola. A quadratic function is a parabola. Now I want you to think about all the work that we did translating, moving around parabolas. We started with the equation y equals x squared. That's your BFF, parabola, right? Then we added things to it. So when we did, x plus 3 squared minus 5, that's this same parabola, but it's been moved, right? How has it been moved? Left 3, down 5. So this vertex would be at -3, -5. So when you're writing your own quadratic function, parabola, if the vertex is at 3, 1, what's that equation going to look like? If the vertex is at 3, 1, what's that going to look like? Y equals x minus 3 squared plus 1. That's it, except for one thing. There is a coefficient out here that has nothing to do with the vertex, but it controls how skinny and which direction your parabola is, right? So we need to figure out what that coefficient is. That's why they gave you this point. Because what are you going to do with this point?
Plug in.
You're going to plug it in. So 2, negative 4 minus 3, plus 1. So we're going to take this point, plug it in for y and x. Make sure you're putting y in for y, x in for x. Start with the parentheses. So the parentheses are negative 7 squared, 49. Do not combine these. They don't combine. This one has an n. So we'll subtract 1 and divide by 49. So in the answer blank, we will write this. Now kids, that's easy. Let's review those steps. First thing you do is take care of, build the equation from the vertex. Remembering that if the vertex is at 3, 1, that means you had to go right 3 and up 1. Then we plugged in that other point for the x and the y and figured out what our n was. And we're real careful here to do things in the right order. Don't combine these, ever. Everybody good? Okay, find the vertex axis of symmetry and direction of opening in the manner of your choice. So I heard somebody say negative b over 2a.
Yeah.
That's probably the quickest way. That depends, I guess, on your personal preference, but negative b over 2a will work for sure. So for this first problem, negative b over 2a would be negative 3?
Yeah.
Yes. So that means my axis of symmetry is x equals negative 3. This is x equals negative b over 2a. So my vertex has an x coordinate of negative 3. Now I'll just plug in, right?
Yep.
So negative 3 squared is 9. Minus 18 minus 4. I'm putting in negative 3. So what is that, negative 13? And which way do I open? Up, because that's a positive x squared. And number 2, or B, is the same exact thing. It's a little bit different, but don't panic. What's my A in this problem?
3.
What's my B?
12. Negative 12.
Negative 12. So I'm all good. X equals negative B over 2A. So I got x equals 2. Did I do that right?
Yep.
So my vertex has an x coordinate of 2.
Yeah.
So I'll plug it in. So I plug it in right here. So watch it, watch it, watch it. We do exponents first. So that's going to be 4 times 3. That's going to be 12. Minus 24, negative 12. And that's a positive number, so it again opens up. Okay? Now, as we go through practice test 3, and we're probably going to get this finished, would you, I know I've already got some check marks on some of those, but make a little notation next to the ones you think are going to be a little confusing for you. Because we have tomorrow to practice some more, and we want to focus on the ones that are confusing to you. So, here we go. Number 1, well shoot, we already did this just a minute ago, but let's do it again. Don't panic. I know there's a fraction. Doesn't matter. Nothing changes. We want to find the vertex and axis of symmetry. We're going to do x equals negative b
Over 2A.
over 2a. Now don't freak out.
That's 1.
What's
Negative 1.
2 times negative 1/2?
Negative 1.
Negative
So
1.
negative 4.
So this is 4 over negative 1?
No, it's over 1, there's no negative.
Oh, there's no negative there? Oh, where'd I get that? I don't know.
The negative.
No, maybe, yeah. I just stuck it in. Sorry about that. We good now?
Yeah.
So there's no negative down there, so it's just x equals 4? So my x, or my axis of symmetry is x equals 4? Which means my vertex is 4 comma something. Now be careful, you're gonna plug 4 in, so you get 1/2, 4 squared, 4 times 4 plus 2. Be sure you are doing this in the right order. 4 squared, start with exponents, PEMDAS, exponents. 4 squared is 16, times 1/2 is, 16 times 1/2, 8. So we have 8 minus 16 plus 2, which is negative 6. And since that is a positive 1/2, it opens up. Right? All right. Next one's exactly the same, a little easier. Axis of symmetry for this one will be negative b over 2a, negative 6. So to get my vertex, I'll plug in negative 6. What's negative 6 squared? 36. What's 12 times negative 6?
Negative 72.
Oh, negative 40. And it opens up. Anybody have a question about that kind of problem? All right, polynomials, A. No. Variable in denominator. B.
No.
No. Negative
Exponent.
exponent. C.
Yes.
Yes. D.
Yes.
Yes. Yes. D is a yes. D is a yes. Nothing wrong with D. It's got a fraction in it, but that fraction is not an exponent, right?
Yep.
So it's good. E.
No.
No. Variable under radical, right? Everybody okay? Now we're going to change to vertex form. Vertex form, guys, is that form we were talking about a minute ago. This is an example of vertex form. So, yeah, just a second. So I'm starting with this. So Olivia says let's divide everything by 4. We are going to complete the square, kids. You're not finding the vertex. You're writing the equation like this. So you cannot do negative b over 2a. You're not finding the vertex. You need to complete the square so your equation looks like this. So the first thing we're going to do is divide everything by 4. This number right here, we're dividing everything by that number. Right?
Yep.
Now, let's move this to the other side. We got 3 over here to the other side. Because we are going to complete the square. We're going to add something, right? What are we going to add? A 1. Why are we adding a 1 to both sides? It's half of 2 squared. So half of 2 is 1. and 1 squared is 1. Over here, we just add those two things together and get minus 2. And then what about these? What always happens that always factors? And when you factor it, the two factors are always exactly the same. So we write it as the factor squared. What are the two factors in this case that are exactly the same? X minus 1, x minus 1. We don't write x minus 1, x minus 1. We write x minus 1 squared. So that our equation will look like this. Well, my equation doesn't quite look like that. So what am I going to have to do? I'm going to add the 2 to the other side. And then it almost looks right. I'll multiply by 4. And when you multiply by 4, you put a 4 on the parentheses, and you multiply that last number by 4. So that is the equation in vertex form. You could do things in a little bit different order. As long as you're ending up with that equation, you're right on target. All right, we got a linear equation. We just did one like this. How do we start? Colin, what do we do first?
You have to make the points.
Make the points. So what would the points be?
1, 3, and 2, 9.
Yep. And then what, Colin? Once I
And
get the
then
points
go
be?
over each other.
What do you mean by that?
X minus X and Y minus Y.
Okay, but it goes the other way around. It's got to be y minus y over x minus x, right? Slope is y over x. So 9 minus 3 over 2 minus 1, that's 6 over 1 or 6. So my slope is 6. Now what? Pick a point, plug it into y equals mx plus b. So if I just pick this one, 3 equals 6 times 1 plus b. So 3 equals 6 plus b, I got negative 3. So what do I write in the answer blank?
Y equals 6x
Minus 3? Perfect. Perfect, perfect, perfect. Now that problem that we did a minute ago where we had to complete the square, this is the vertex form. So now you're going to do the same thing. The vertex is -1, -2, and we contain the point 2, 3, and you're going to come up with an equation that looks just like this. Okay? I'll take your hood off, please. Now, where do I start? The first step is super simple.
Equals n x minus 2 squared plus 3.
So y equals x plus 1 squared plus 2. Oh wait, plus 2? Minus 2. That has a vertex that goes left 1 and down 2. Right, Jalen?
Yeah.
Okay. Now how do I find that coefficient out there in front?
Plug in Y.
I plug in this point.
Yep.
So 3 equals n times 2 plus 1 squared minus 2.
Yes.
Don't mess this up. PEMDAS. What's the parentheses? 3 squared is 9. So this is 9n. Don't combine don't do that. You can't do anything here. We're solving for n, so we'll add 2 and divide. And that goes right here. And that's the answer to the question. Emma, you paying attention, Madeline?
Yeah.
Okay. All right. Good job. We're on the next page. Let's see what we got on the next page. Write the equation. All right. This is a little different this morning. Maybe we haven't done this. So how do we start? What's step 1? Find the. Yeah, again, I didn't label. What is wrong with me? So when I set up my equation, we're going to have how many parentheses? 3, because there are 3 x-intercepts, 3 points on the x-axis. Remember, it's only the ones on the x-axis we look at. So I've got 1 at so that'd be x plus 2, x plus 1, x minus 2. Okay, so step 1, get those parentheses built. Now, step 2 is the step we sometimes forget. What do we need to pay attention to? Bouncing. So is anything bouncing? It's bouncing at this one right here. Does everybody understand what I mean by bouncing?
Yeah.
It's not passing through? What's that 1, 2 point in there for?
There's a number that has nothing to do with it.
There's a number that has nothing to do with the parentheses, but I have to figure out what it is. And that's what I'll plug the 2 and 1 in for. So 2 goes in for y and 1 goes in for x. So that would be a 3. Watch it. This actually would be a 4 and a negative 1. Did you get negative 1/6?
Yeah.
So this is what you write in the answer blank, right there. Does it make sense that that number is negative?
Yes.
Why?
Because they both end down.
Down. Yeah, we don't have anything that ends down unless it's a negative even power. So there we go. Any questions about that procedure? All right, let's see, that's 6, 7. The height of a ball above the ground at t seconds is given by this equation. Find the maximum height and the time it is reached. Maximum. What does that word, when we say that word, what clues into your head when we say maximum? Highest point, which in parabola vocabulary is called the vertex. So we need to find the vertex. And we have a formula that helps us do that, right? It's no different than those other problems. So negative b over 2a would be negative 48 over negative 32, which is 1.5. 3/2, 1.5. So my x coordinate's 1.5. How do I find my y coordinate? I'll plug it in. I got 38. Hopefully that's right, 38. And I got that by simply plugging 1.5 in for the t's.
Which one's time and which one's
Well, I don't know. What do you think? Look at the equation. See the h? In a regular equation, what letter would be over here? Y. So y is the height. So this is 38 feet. In a regular equation, what letter would be here? X. So this is the time. So when does it reach its highest point? 1.5 seconds. What is its highest point? 38 feet. Think of a regular equation that would be written like this, right? So x is the time, y is the height. Synthetically divide, and you know I'm gonna get tricky, folks. What do we have to just be on the lookout for?
Zeros.
Zeros. You know there's gonna be a zero stuck in there somewhere. So in this case, we have a 0 after the 8 and before the 9. Would you agree with that? Positive 1 out here in the box. Kids, it's always the opposite. It's where the dot would be if you were putting a dot. And if you have a parentheses, x minus 1, the dot would be at 1 if you were graphing it. The box is the dot. Alright, I always get careless here, so let's take a look at that, make sure I'm right. Somebody either confirm or that looks okay?
Yeah.
So then there's 2 answer blanks, there's a quotient answer blank and there's a remainder answer blank. In the quotient line, you're going to put 2x to the third minus 6x squared minus 6x plus 3, stop, that's the quotient. And then on the remainder line, you'll either write just the number 3, this is the remainder. Oh wait, no it's not.
That's 1.
1, I was looking at the wrong line. This is the remainder.
You did it again.
Did I do it again?
Yeah.
What did I
You
do?
put 3. It's 1. Wait, no.
No,
Never
that
mind.
is
My
three.
bad.
1
bad.
is here, that 1 is there. Or, if you want to put 1 over x minus 1, you can. Here's my division line right here. So 2x cubed, 6x squared, 6x, and 3. And then there's my remainder right there. That 1 is my remainder. Or you can write that if you want. All right? PRRs.
2 and 1, plus or minus 2.
There aren't very many for this problem because that last number is a 2. So your PRRs, what you're gonna list on your paper, plus or minus, always plus or minus, 2 and 1 over 1.
It's try 2.
So that's it for that question, okay? Then the next question says, find them. What are the roots? Well, we take something from this pile right here, and we try to do a division. So what do you want to try?
X minus 2.
So you want to try 2?
Yep.
Now chances are, you're going to have to do this a couple times on the test, so chances are you're going to guess wrong. And if you guess wrong, that's fine, you just guess again. So you pick a number, try to do the division. This one worked out great. Directions say find the roots. So one of my roots is x equals 2. It divided in evenly. If I were graphing this, there would be a dot at 2. But there are supposed to be 3 answers, x cubed, 3 answers. How am I going to find the other 2?
Factor.
I take what's left which is x squared plus 9x plus 1. And in an ideal world, it would factor, right? But this isn't an ideal world, and that does not factor. So if it doesn't factor, we're going to have to use the quadratic formula. And I promise you there will be one question on the test where you have to do this. So here we go. Negative b plus or minus the square root of b squared minus 4ac all over 2a. What have I got under that radical?
77.
Great number. So this is negative 9 plus or minus the square root of 77 over 2. That one does not simplify. Here are the other two answers. You're not graphing this. You're not worried about it at all. Those are the answers. Done. Okay. Number 10 is kind of the same, except you don't have to guess. They tell you that one of the factors is x plus 2. And you're going to find the other ones. So what do?
You synthetic
You divide. Kids, these are exactly the same problem. The only difference is here you were left on your own. You had to guess. Here you don't even have to guess. They're telling you to divide out negative 2. Why am I dividing out negative 2? Because the factor is x plus 2.
Yep.
So here we go. And this is going to work. They told me it was a factor, so I know it's going to work. So what do I do now?
Yes.
factor.
I don't need to guess. I could guess, but it's probably easier not to guess.
Factor.
This is x squared plus 10x plus 21 and 7 and 3. So it says, what are the other two factors? X plus 7 and x plus 3. What do you think? You all right with that? All right, next problem. Volume varies inversely as pressure. What do you think of when you see or read volume varies inversely as pressure?
V equals K over P.
V equals K over P. Beautiful. Inverse. Volume varies inversely as pressure. If the pressure is 12, watch it now, make sure you're putting it in the right spot. The volume is 5. So K equals 60. Emma, you okay?
Mm-hmm.
So volume equals 60 over P. I know K is 60. So here's my framework for this problem. Find the pressure when the volume is 16. Find the pressure when the volume is 16. Is that okay?
Yep.
Now, get rid of the fraction first. So multiply both sides by P. And then divide by 16.
Yep.
So you can type that in your calculator. You can also reduce that. 15/4, which is what, 3.75? Here's another one. Find the possible rational roots. Okay. What are the possible rational roots of this one?
8, 4, plus or minus 8, 4.
Plus or minus, good. 8, 4, 2 and 1.
Try 4.
1.
8.
4.
8.
Ellen, 4.
8. I'm gonna go with, let's say 8 just cause. -8.
Alright, I'm gonna just branch out. I'm gonna try -1. I'm gonna try -1. And let's see what happens if I try -1. Now, this is not a group test, so you're not gonna have the advantage of everybody working ahead and finding one. You're gonna be on your own. So you just choose a number, divide it in, and hope like heck this comes out to be 0. If it doesn't, then take another number, divide it in, and you're gonna find one within your first couple of guesses. Unless, yeah. There we go. So the direction said, find the factors. Well, one of the factors, there's 3 of them, and one of them was x plus 1. How do I know it was x plus 1? Because I divided in -1, which means the dot is at -1. And if the dot's at -1, the factor is x plus 1. All right, can I get the other 2 factors from this?
Yes.
X squared minus 6x plus 8.
-4 and -2.
X minus 4 minus 2. So those of you that were shouting out numbers for me to try, I guessed -1, but I could have guessed 4. Remember Olivia was over there saying try 4, 4, 4. Yep, it worked. And so did 2. So whoever was over here saying try 2, 2 worked. Those of you that said try 8 didn't work. All right, bracket. Any bouncing or anything going on in this problem? No. This is just a plain old cubic curve. They're easy to sketch. How do you feel about that, okay? All right, number 13. Oh my goodness, you're right, we only have 2 more to go. All right, so number 13, what's happening there? Now this is a sketch that's a little more complicated. So where do we start? Is this a circle? It would be a circle if, well actually no, it wouldn't be a circle. If there were a plus sign between them, and if one of these was a y instead of an x, but no, this isn't a circle, this is a polynomial. Well, I gotta think of something, there's...
Positive 1 or -1 and positive.
So I'm gonna have a dot at -1, and I'm gonna have a dot at 2. Now I also see some squares in there, so I know I'm going to be doing some bouncing, right? But before I get ready to bounce, I have to know whether I'm coming in from the bottom or in from the top. So I gotta pay attention. I have 4 x's, right? That's even. Normally I would be up, up. But because there's a negative, I'm going to be starting down. Bo, does that all make sense to you? Bo, don't just say yes. It does? Okay. I never feel like I know what's going on here. All right, so it's coming in from the bottom. When it hits that, it's gonna bounce, right? And it's gonna come connect to this one. And then when it hits that one, it is also going to bounce. So that's the shape we have.
Do you want us to do the y-intercept on that?
You do not have to do the y-intercept. You do not have to plot the y-intercept. We haven't been doing that. It's not fair for me to throw that in here. You could certainly, but I'm not going to require it. Okay? And the last, factor and sketch. So really, I'm erasing one. Didn't number 12 say basically the same thing? The only difference was in number 12, I had you list the PRRs. I'm not having you do that in number 14, but could you?
Yes, good.
You could do the PRRs, but you don't have to if you notice that this one groups. Now, if you want to do the PRRs and guess and divide, that will work, not a problem at all. But if you're attentive, you can see that this one factors by grouping. And that's usually quicker. So I have a common factor of x plus 2, right? And then I have x squared minus 4. Now remember, if you're going to do it this way, when you write that common factor, you don't square it or anything, you just write x plus 2. But this time, I don't remember this happening before. This time,
X plus 2
I
squared.
have 2 x plus 2's. Now, it's okay to write it this way, but it might help you in terms of graphing to write it this way. Because now you know you're going to have a bounce. Another yawn. I don't get it. This is such good stuff. All right, so I have a dot at -2 and a dot at +2. Now, this was a cube, right? Regular old cube. So it's starting down here.
Bouncing and finishing
Now, be careful. The bounce is where the dot is -2, right? That's where the bounce is. So it's going to bounce here and go through there. And we just finished practice test 3.
Could you draw it as if it was x plus 2 cubed? So,
That one is not x plus 2 cubed.
could you draw it as if it was? Like, what's the shape you want to see?
If you factored something, and let's say it came out to be this. Or it came out to be that. When you factored it, that shape would be a squiggle. But what you need to be careful of is, it is definitely squiggling through -2. But pay attention, the degree of the polynomial is 4. So it's starting up. It's going to squiggle through that one, and then turn around and just pass back through that one. Okay? Anything else that you can think of?